So in this video, I want to talk about actually what we're talking about is what we call the fundamental theorem of algebra. And what the fundamental theorem of algebra says is that for any polynomial of degree n, it says for any polynomial of degree n, there exists n amount of roots, up to n amount of roots for that particular polynomial. So what that essentially means that if I take a polynomial, we'll call that polynomial p of x, and we'll let that equal ax to the n plus all the way down to some constant term p. No matter the polynomial, we're always focusing on this leading coefficient term here. This n sitting right here will tell me how many roots or how many solutions I need for that polynomial. So if you look at this equation over here, the first example, x to the third minus 3x squared plus x minus 3, then for this particular equation, this is leading coefficient, there should be 3 solutions. Now, the problem with those 3 solutions is we don't know if they're going to be real or if they're going to be imaginary. The thing you do need to know is that imaginary pairs, imaginary solutions, are written of the form A plus BI, where again, A is the real and BI is the imaginary. In this particular case, all imaginary solutions come in pairs. So the solution would be A plus BI is a solution and A minus BI is conjugate. That's called the conjugate. So essentially, this means that if you're looking for solutions, if you have an odd number of solutions and you only get one real solution, the other 2 have to be the imaginary pairs. And here's the example, x cubed minus 3x squared plus x minus 3. We can help shorten this process a little by graphing this function and looking for where it crosses the x-axis at. So I'm going to go ahead and graph this function first and show you what I mean by this. So if we're graphing the function, bring it out here so we can see it. X cubed minus 3x squared plus x minus 3. We know that it should be 3 solutions. If I look at this, when I look at this equation right here, I only see one real solution. It only crosses the x-axis one time, and it's crossing the x-axis at the point 3, 0. So x equals 3 is a solution there. The problem with that, though, is that from the fundamental theorem, it tells me I need 3 solutions. So I know that one of my solutions is 3. Right? So we're going to find all the zeros of the polynomials. The first 0 is going to be 3. To find the other 2 zeros, because when I look at the graph and only cross the x-axis at, remember, that one value, the other 2 are going to have to be imaginary. So to find those imaginary solutions, what we do is we start with the synthetic division process. So put 3 here, use the solution, and then we're going to go to our coefficients, which are 1, negative 3, 1, negative 3. Bring it down. 3 times 1 is 3, that's a 0. 3 times 0 is 0, that's a 1. 3 times 1 is 3, that's a 0. What we're trying to get this to is a quadratic equation, because you should know how to factor quadratic equations. And remember, in a synthetic division process, we always write it down 1 degree less than where we started. So this will be x squared plus 1 is equal to 0. Now, to factor x squared plus 1 equals 0, there's a couple ways we can do it. We're going to use the square root method. So we're just going to subtract 1 on both sides, and we get x squared equals negative 1. problem trying to take the square root of a negative number is it doesn't exist. There's no real solution for that. So we take the square root of this and we get an imaginary. And my imaginary solutions are x is equal to plus or minus square root of negative 1. By definition, the imaginary unit, also known as I is equal to the square root of negative 1. So what we get here is plus or minus I. So now I have my solutions, which are x equals 3 and x equals plus or minus I. And then they want us to write the linear factorization of these solutions. Well, the linear factorization means whatever the solution is, you need to go back and reverse its sign. So my solutions would be for linear factorization, x minus 3, because that gives me this solution. Then x minus I, that gives me the positive, and then x plus I, x plus I gives me the negative solution. And those are my three solutions. And if you were to factor this out, you would see that this is going to give you the actual equation that we started with. And I'll show it to you right here. So we have x minus 3 times x minus I, x plus I. We're going to work these two first. We're going to distribute those two. So when I factor those, here's what I get. X times x squared, x times I, xi, negative x times I, negative xi. Negative I times the positive I is a negative I squared. So these terms are going to cancel. I'm left with x squared, and then this part, negative I squared. I squared is equal to negative 1 by definition, because square root of I is equal to the square root of negative 1. So when you square the square root of negative 1, you get negative 1. So I essentially have x squared, a negative I, a negative times negative 1. You're doing this negative right here times negative 1. That's equal to positive 1. I'm going to multiply that by x minus 3. And when I do that, I get this right here, x times x squared, x cubed, x times 1, positive x, negative 3 times x squared, negative 3x squared, and negative 3 times 1 is a negative 3. If I rewrite that in standard form, I get x cubed minus 3x squared plus x minus 3. And that shows that this is the linear factorization. This term right here is the linear factorization of this right here.